Okay, let's do something a little bit easier than that range video, yeah? And that's the y-intercept. Okay, the y-intercept of a rational function, right? Y-intercept has different definitions. One of them is the point where the graph crosses the y-axis, okay? But we like to use the definition that it is the value of y when x equals 0, okay? And when it comes to a rational function, there's an easy way to figure this out, right? Now, there's always the option where we can take 0 and we can plug it into the function. Okay, so even if we go through this process once, just as an example, we might as well. Okay, so we're plugging in 0 everywhere we see an x. Now what happens here? We end up with 0 plus 0 minus 20 over 0 minus 16. So we get an overall value here of negative 20 over negative 16. And you should know from your previous schooling that in a fraction, two negatives, right? A negative divided by a negative is a positive, and 20 divided by 16 are both divisible by 5. So this is 5/4. So we would say that the y-intercept is 5/4 when x equals 0, okay? Also known as 1.25. Now, I told you there'd be a little bit of a shortcut here, and it's this, right? If we're plugging a 0 in for x, any x term in this entire rational function basically goes away. So when you're talking about the y-intercept, all you need to do is look at the ratio of these two constants, of the floating constants. I've called them in previous videos, right? The floating constant in the numerator is negative 20. The floating constant in the denominator is negative 16. All those x terms became zeros, right? So this is a sort of a shortcut for doing this algebraically. Just cover up all the x terms, even the ones that are squared, cubed, whatever, doesn't matter. And whatever is left over, that's where your y-intercept is going to be, okay? And we can verify that from the graph. Obviously, pretty quick check. This is that same function I kept here on the graph, the y-intercept at 1.25, which is 5/4. Okay, so the graph is still good, but if you're doing this algebraically, cover up the x terms, and whatever's left over on the top and the bottom, that's your y-intercept.